Right, so basically what we're looking at is the building here. As you can tell, these elevations here, you go straight to the drawing, you have a look at it, and I think it's elevation C. As you can see there, this is the elevation that's directly opposite the train track. Okay, so if we go back to our drawings here, you can see this elevation here. It's a step elevation, so it's gone stepwise. I think at the highest elevation, that is 7 floors. So if we go back to it, elevation C, as you can see the stepped, you see it there, 2 steps there. And if we count ground floor, first floor, second floor, third floor, fourth floor, fifth floor, sixth floor, seventh floor. So this is the elevation that we're looking at here. Looking at it here, so you can see the ground and first haven't got the cladding panels. The first and second, ground and first, so second to 7. Okay, go back. From what we've ascertained just now, we're going to need to apply for a rail permit for this particular location here. Why? Because if you erect scaffolding up to about how many here? 800. We don't know how much, anyways, but I think the height of the building is about 21.9 meters, and the distance between the lowest point and the rail track is about 21 meters, 21.2 meters. So you'd have to ascertain that if the scaffolding were to drop over, would it hit the rail line? So you'd have to enter into some sort of agreement with Network Rail and make application, to see if, that there is any risk potentially to the rail track. And obviously you can see it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 lines. And these look like major lines that come into Waterloo and London Bridge from out of London. So this is obviously a key piece of property for Network Rail. So now, in order to find out what the potentially, if you're at high risk to the scaffolding dropping and hitting this, you could do a series of calculations. Okay, so let's just quickly do some calculations here to try and ascertain the possibility of the scaffolding collapsing. Okay, so if we go to PowerPoint. Okay. Slideshow. Beginning. So what we could do is draw, say, elevation C. This is the edge of the building, right? This is just a rough drawing, and this is the railway. Okay, so these are all arches. Train. Pardon my drawing skills. I'm having to do this on a piece of paper, basically. So we say this is 21.9. Okay, and this is 1. So just doing a rough calculation, you can ascertain obviously what the trajectory of that would be. Okay, so if we say that this is A, B, and C. Okay, so this is a right angle triangle. We can ascertain what the distance between here to here will be using a basic Pythagoras theorem, which will be A. Do you remember Pythagoras theorem? A squared B squared is equal to C squared. Yeah. So A squared C squared. Okay. So we have A and we have B. Let's just say 21.9. 21.9 that gives us 479. Let's just say 479. Okay. 21 squared. Yeah. Go to 44.9. Equal to what? C squared. So if you add the two together, 479, and then you square root of 928.44. Square root of 928.44. The answer to that is 30.47. Just 30.47 meters. So the distance between there and there is 30.47 meters. If this length is 21.9, if it were to drop, when the scaffolding drops, it drops, let's just say this is the scaffolding. You've got to remember the scaffolding would be tied into the wall at 1 meter distance from the wall. So you have to take off the 1 meter here, and this will give you a 20.9. You should have taken off a 1 meter here to give you 20.9. So the scaffolding will drop that distance, hyperbola down, worst case scenario. Okay, so the distance between there and there is that if it drops 20.9, it would fall in a straight line and it would just miss that. So a simple calculation like that would help you ascertain and avert the risk. The risk is minimal. Okay, so now ideally the application would take 8 weeks after making a phone call to Network Rail. They've ascertained that it would take 8 weeks for us to make that application. All right, so that then negates the sequence that you can work on. This is elevation B up to there, and this is elevation C up to there. That would mean that you would only work on elevation C up to this point. Obviously, is elevation C, I think. Let's have a look. So this is elevation C. So let's work from the grid to see. This is elevation C. That goes all the way to where this is